Good afternoon, everybody. This is Frank Spivak with the Energy Conservatory, and we are going to provide you with an introduction of the new DG-1000 digital pressure and flow gauge. This is a project that we've been working on for a couple of years. During this session, we'll talk a little bit about the history of what got us here, talk about the DG-700, and then we'll talk about the DG-1000 and all of its various features. So with that, let's talk about the agenda. What are we going to talk about today? So why are we developing a new digital pressure and flow gauge? How did we get started? The work in progress, the specifications that the new gauge has. We'll also provide a live demonstration so that you can see the gauge in action, and then talk about ordering and availability. So the new gauge, let's talk a little bit about brief history of the DG-700 and the future of the 700, because that's really quite integral into our DG-1000. The DG-2 and 3 were the first electronic pressure gauges doing building science, dedicated to building science work, starting in around 1993, and that was really to provide more accurate readings when compared to Magnehelic gauges. Magnehelics have been around for decades and decades, but have always been subject to interpretation and various issues surrounding the readings and accuracy. So while the DG-2 and 3 was modern for its time, the underlying technology became obsolete. So the idea for replacing the DG-2 and 3 began in about 1999. We then had a plan in mind, and we began serious development in 2001, and the gauge finally came out in 2003. The DG-700 had several improvements over its lifespan to provide more features to our users. One is cruise. When the gauge first came out, it didn't have it on there. Cruise was added and became the first gauge to be able to use to easily do cruising of a blower door without the use of a computer. We also later on added a USB port. The gauge originally and still has a serial port on the top of the gauge. We added a USB port just to make it a little bit more easier to connect to laptop computers that are out in the field. And then to further extend the use of the DG-700, we developed the Wi-Fi link. This had the potential of adding Wi-Fi connectivity to well over 30,000 gauges that the Energy Conservatory had in the field. The DG-700, when it was developed in 2003, used what is called a ZMix processor chip, and at the time was really a cutting-edge device for handheld instrumentation. We also incorporated the latest piezoelectric pressure sensor technology. The sensor inside a DG-700 was roughly 1/8 to 1/10 the size of the pressure sensor that was in the DG-3. So a lot of technology had changed, and we were able to take advantage of that. The DG-700, when it came out, was a 1%, and still is a 1% accuracy instrument with stable zero readings. So it's still it's still an industry-leading gauge for being able to read pressure values at everything from 0 all the way up to 1250 pascals. And as time marches on, we found out that the ZMix chip was no longer going to be manufactured. It was developed by a company in Austria, and That particular chip had a lot of limitations that newer processors were able to take over. So they discontinued discontinued the manufacturing of the ZMix chip. So we roughly have enough supply on hand to manufacture DG-700s at our current rate for about 2 years, and are able to provide support for our DG-700 for at least 10 years. So we hope that those that have our gauge can continue to use them for a long period of time, and those that still wish to have an industry-leading gauge but don't necessarily need all of the new features can still purchase a DG-700. So we'll continue to do that for about 2 more years. We will also continue to sell the Wi-Fi link for a number of years because people can add the Wi-Fi connection. We see that that is something that's not going to go away. So adding Wi-Fi connection to the DG-700 is really a nice advantage. So why a new gauge? Well, computer technology has advanced more in the last 10 years than it has in the previous 30 years. So we see a lot of things changing with computer processors getting smaller and more powerful than ever. This allows for a lot of capabilities. We're also seeing a lot of use in the field by raters and raters and testers. Their technology that they're using is advancing at a faster rate as well. So it was natural that we then looked at what could we do that would have something that's rugged and durable, and we see that the displays that are out there now are much better and truly usable for field applications. So we had to move forward with something that matched what was happening out in the field. As the testers and raters are using more technology, something that we could develop that would match that was equally important. So how did we get started? The first was a review of technology. Everything was on the table for discussion. We wanted to look at processors. We wanted to look at displays. We also wanted to look at sensors and connectivity. What are people doing? All of these basically starting from scratch. Yes, we have a DG-700, but what's the current state of technology and what can we do with that to create something that's really useful? We also wanted some outside perspective. We thought that it would be good to hear what others know about handheld instrumentation. What do they know about the design of handheld devices? So we wanted to get an outside perspective to help us develop our next new gauge. We wanted some new ideas, and you'll see some of those ideas in just a few moments. And we needed more design capability. So coming up with a gauge required the use of more designers and people to create all the intricate drawings necessary for a new gauge. And we wanted experience with voice of the customer. So we had a design firm that helped us generate some questions and images and graphics necessary for us to be able to poll and ask our customers various questions related to handheld instrumentation. So we used a company called Brownlee Design, and one of the first things that we wanted to find out was, what do people think of user interface? Now, we started this back in October of 2014. So at that time, we asked the question, about user interfaces. We presented people with the fact that our next new gauge will have accuracy of 1% of reading, 2-year calibration, built-in Wi-Fi, built-in fan speed control, replaceable batteries, replaceable rechargeable batteries. It'll have some sort of USB connection as well as an Ethernet connection. That it will have some sort of ergonomic case design. We're also looking at hose and cable connections, power and Wi-Fi switches, and most importantly, simple logical screen graphics. So the discussion was, this is all a given. The next step is help us with what it is that you would like to see in a gauge. So over time, we asked people to express their preferences, give comments on different gauge styles. From this drawing, you see models A, B, C, and D. Of this group, 2 are touchscreen, 2 are button technology, 2 are color, 2 are black and white. And we described how some of the features of these particular gauges might play out. So there'd be less navigation in a touchscreen display, but more navigation capabilities in a button type of gauge. You'll have to scroll for numbers as opposed to using a numeric keypad. The touchscreen might be a little less durable than the button technology, and given color or black and white, there might be a trade-off in battery life. So after asking a lot of different questions of a lot of different people, it became obvious that Model A was what people wanted to see. So given that this was still almost 2 years ago, we saw people with a preference for touchscreen color technology because that's what they're seeing in their smartphones. So the next step was, what's the gauge actually going to look like? So we took that screen design and had our design company give us a series of concepts. What could a new gauge look like? Now you'll notice one of the feature characteristics of these gauges has the pressure taps away from the face of the gauge. They're on the sides or on the bottom, but they're not on the face like the DG-700. We know that having tubing on the face can be a little difficult for people to just hit the buttons, and we didn't want that to take place. So we wanted a nice clean look. So you can see that all of these incorporated a way to move the tubing away from the face of the gauge. But you also notice that none of them have it on the top because tubing on the top didn't make a lot of sense, because when it's on the top, it always drapes over something. So we took these ideas and we passed them around to people inside, both management and staff, showed them to people outside, just to get a few, to get some feel of what things people liked and didn't like. A lot of polling and a lot of trying to understand why people liked certain designs. So when we were done, it came down to the fact that people thought a horizontal design might be something really unique and be able to provide a nice display and show the kind of information that we want to our users on what it is that they're testing. So we chose this particular model, but at the same time we said this is really complicated. We want it to be a lot simpler. So one of the things that somebody had bought recently was a GPS device, and noticed how the lines were really clean, very smooth, simple curves. So we told our designers, take this idea, but make it simpler, and give us something to work with. So they came up and said, okay, that's fine, we can do that. Now we need to figure out how big the case needs to be and what is it that's actually going to be inside the case. So, excuse me, we had all of our engineers work together and come up with what is it that actually goes inside the gauge? What is it that we need? So you can see the picture in the upper left is an edge view. You can see two batteries. We have connectors, tubing ports. The upper right shows the fact that there's a processor board of some kind, the auto zero valves and pressure sensors and some connectors. The lower, or the center right shows the display and how that would be put together, and the lower left, what it would look like just face on. So we figured this is kind of our constraints. This is what has to fit inside a carrying case, inside an instrument case. So then they came up with 3 variations on a theme, and the end result was something between Model A and Model C. And many of you have probably seen this in our ads and at various trade shows when we've shown samples of our work. So we took this original design to the ACI conference in 2015 to New Orleans. We wanted to show an approximate size and weight. We had a sample display of what we were choosing, although the gauge wouldn't work, so it wasn't a functioning display, but we wanted to give people an idea of the size of the display. We wanted people to have a look and feel and give us responses to that. We also had a computer simulation of the display, you know, telling people this is going to be a touchscreen display, and here is approximately what the graphics are going to look like. So it was our way to get feedback on our direction. Is this the right direction? Are we way off base? As well as getting voice of the customer comments on things that they liked, they didn't like, things that they would like to see tweaked, and so on. So when we left the ACI conference, that's when the work really began. We had to refine all of the case and components. We had a 3D prototype put together with a bunch of things stuck in, but not a lot of wires connected and things like that. So we needed to really start working on making it much more of a final design. As we came up with that final design, we had to purchase parts and even get the injection mold for the case. And some of you may or may not be familiar with this process, but even just getting the mold to run product is about a 20-week lead time. So in the process, we're refining parts, moving forward, but also then doing a lot of waiting. But there's a lot of work being done during that waiting period. The biggest task in this is programming, because this particular gauge has a full operating system inside it. This is not a limited microprocessor chip. This is a full functioning computer with an operating system that we have been able to adapt and use with our particular product. So looking back at the DG-700, the internal firmware for a ZMix chip had a maximum space of 16K. 16K translates into 16,000 bytes. The DG-1000 is currently at 200 million bytes of data, roughly 12,000 times the amount of code that our DG-700 had, so that we could provide all of the features and how this will work for our customers. And we're not done, because the gauge is an updatable gauge, and we expect it to have more features and more functions in the future. So we will be adding to this total amount of coating to make sure that we have a product that customers can use. So electronics, giving you an idea of the fact that on the left is what the electronics board of the DG-700 looks like, and on the right you can see the DG-1000. There's quite a lot more involved in the 1000 than our previous gauge. And the pressure engine has changed. On the left you see the DG-700 pressure engine with the auto zero valves on the left, and the upper center you'll see the two sensors. For the DG-1000 we have them encapsulated inside a metal case to allow to increase the ability of the gauge to reject electromagnetic interference and radio frequency interference. So schedules, we were originally hoping that we would be shipping by late 2015, but as we go from changing complexity to simplicity, it takes a lot of time. We also provided a lot of internal testing and user testing, and each time we did that, we came up with items that needed to be changed or modified to make it easier to use, more of a solid functioning device. So every time we did show the device, we had to make some changes. So that kept adding to the complexity. We also had developed a series of specifications, and we've been working on this for quite a long time, and what it is that we're going to have with our new DG-1000. And we've had, in the past, we've been able to say all of our specifications will be as good or better than the DG-1000, our DG-700. I'm very pleased to report that the DG-1000 will have a new pressure range of plus or minus 2,500 pascals. So this is double the range of our existing DG-700. I'm also very pleased to announce that the accuracy for the DG-1000 is better than the DG-700. So this is 0.9% of the pressure reading or 0.12 pascals, whichever is greater. So with this specification and a 2-year calibration interval, this will easily meet all of the existing standards that talk about accuracy for building science testing. What is actually more amazing about the DG-1000 is that it's far more accurate than that. As the gauge is calibrated, it will actually have an accuracy of 0.3%. So under laboratory conditions, 67 to 77 degrees, and using 5-second averages, the gauge is far more accurate. In other webinars, when we've talked about calibration of gauges, one of the things that takes effect is drift. And so one of the things that we know in our calculations is that after about 4 months, the average amount of drift will start to affect the instrument, and that will move us outside of this 0.3% of reading. But all of the gauges that leave here, whenever they're calibrated, either new or is when they eventually start coming back for recalibration, all of our gauges are going to be verified to meet the specification at all pressure, at all calibration pressures. So this is truly a step-changing instrument in accuracy. Some of the other specifications. The display is a capacitive touchscreen color, so it's just like your smartphone. It has an adjustable screen brightness with the default at 40%. So you can bring it down to as low as 10%, and you can bring it as high as 100%, depending on what the viewing conditions are. 40% works. 40% is very viewable under most conditions and provides the greatest amount of battery life. Reducing the screen brightness, just like it does on your smartphone, will increase battery life. But we also know that given our current technology with the batteries that we're planning to use, that the replaceable rechargeable lithium-ion batteries will provide at least 15 hours of continuous use. And even with the Wi-Fi enabled, you're going to get 13 hours. So we think that this is truly a great working instrument. We've also done drop testing. So a lot of people have looked at that display and said, oh, that can't be very durable, and the case can't be very durable. Well, the case itself is a far better plastic material than the DG-1000, and we've done drop testing to 5 feet, and it's really a solid device. We also have a new carrying case that holds the DG-1000, the battery charger, a micro USB cable, tubing, and as well as a recovery disk. Because this is a computer, just like your Windows computer or Macintosh, this is we've provided a recovery disk, because when you have the gauge will have the ability to update over the internet. And if anything goes wrong, we want to make sure that you have a recovery disk to get it back into its proper condition. We don't want you stuck out in the field. So it does have internet update capabilities. The new case will fit within the blower door accessory case or even the duct blaster carrying case. So now let's switch over to a live demonstration. So hopefully I can make this work. Bear with us. So now I'm going to share my screen. And you should see now the DG-1000. When the DG-1000 is turned on, you will see that it has 4 icons right now. One is for the gauge, one is for updates, one is for universal settings of the gauge, and another is power off. You see on the front that we have all of our pressure ports. This is channel A input, this is channel A reference, channel B input, and channel B reference. And when we turn the gauge app on, you'll see how that's displayed on the gauge itself. You can see over here, this is a speaker outlet. So different functions, the gauge will make a sound to let you know that it's on. And when the gauge is doing fan speed control, if the fan speed control is being maximized, you'll get a tone from that. So let's tip the gauge up. And what you see here, this is the on-off button. You see the green light that it's on. So similar to some smartphones, when you press the on button, you'll see the green light come on, but the screen may not be on right away. This is the micro USB port, which in the future we're looking for this to be able to send data from the gauge to a computer, but it also is a slow charging circuit. That's why there's a light right next to that connected to it. We also have a full-size USB port, which again, we're looking for future options with this. And right now, the capability of this port is you could connect a USB mouse or a USB keyboard. A little difficult to use, but that's the capability. We also have an Ethernet port, which is going to be used for more automated testing and connecting to your computer. Right now, it's set up that you can use this as connecting to a router. Eventually, you'll be able to just connect to a PC directly. This is the fast charging port and the light associated with that while it's charging. And then this is the fan speed control, just like you see on a DG-1000. So now when we turn the gauge over, you see the calibration sticker for the gauge, giving you the model number and serial number and the calibration date. The fact that this is NIST traceable, and that the calibration interval is 24 months. We've added some barcoding here for us so that when we do have instruments coming back and forth, that we're able to track them a little bit more easily. This compartment here is the battery compartment, and inside there are two 18650 lithium-ion batteries. These can be removed and recharged in a standard rechargeable dock, but you can still recharge this in the gauge as it is. Over here, we also have, you see this symbol here, this is for an SD card. This is our location for the SD card recovery disk. We also believe that in the future that may be a location for some data management. The other features of the gauge include magnets. This allows you, the user, to be able to put the gauge up on the door of the metal door of a house, or at the ductwork or water heater when doing some testing. So it's just a way to add more functionality. They're far enough apart so that the gauge still has a lot of stability when sitting on a counter. So let's kind of move into some of the features. So the settings, let's just hit the settings first. So what you see on there is the network configuration. This is where you would choose Ethernet or Wi-Fi, Wi-Fi to a router, or Wi-Fi directly to a computer. Here's our screen brightness. You can see right now I've got it set at 12% just so that you're able to see it. This also has an auto off time feature. So it can be set for 30 minutes. It can be set to as low as 10 minutes, but as high as never. And then also you see here gauge information. So it's a little difficult to see, but this says the model number is the DG-1000. This gives the software version, the serial number, and the date of last calibration. So all of that information is easily accessible from the front of the gauge. I'm just going to give you a little idea of the screen brightness feature. You can see that it comes up with a sliding bar. I can turn it up, and then I can turn it back down again. Same for the auto off time frame. You can change by moving the slider to various locations. And this means that if the gauge hasn't been touched for 30 minutes, it'll automatically turn off. So let's go over to some of our others. Now this one, I'm going to hit the update. This says update, fetching updates failed, because we haven't got an internet connection. So when I connect to a Wi-Fi signal that has internet connection, the gauge will actually go out to the internet, look to see if there's a new update, and ask you if you want to install the new update. Now, this is the best part. Switch over to the gauge. This is really an interesting interface. We hope that you like it. Several things that you'll see. Up here is the time average, and you can adjust that just by pressing on it, and you'll see the options of 1, 5, 10 seconds, or long term. Just keep that on 1 second. We have the fan speed slider, so you can manually adjust what you want the fan speed to go to. So we can turn it on. You can see it's responsive, moving back and forth. If I leave it in place, you'll notice that there is now a stop button that shows up on the screen. And when I push the stop button, you see fan stopped, and the fan speed slider went all the way to the bottom. We have the cruise function, which has a number of things built in. So we have 75, 50, 25, plus 0, minus 0, but we also have custom. So if I hit custom, I can choose a number. So if I wanted to pick 16 as my cruise target, I would hit OK. Cruise target updated. All I need to do is press the go button. Cruise has started, and you can see the fan speed slider moving. Now eventually it'll go maximum speed because we aren't hooked up to anything at present. And there's your notification. So that's the top half. We also have some settings on here. Over here we have the ability to enter area and volume, as well as change the fan adjust rate. So with area, we can plug in either the floor area of the house for duct or envelope testing for various metrics. We can also put in the area of the exterior of the house if we're doing an envelope test. Volume of the house is important when we're doing things like air changes per hour. So now here we're back to the main part. Here's channel A and channel B. There's really nothing to change on channel A because it's always reading pressure. We can set a baseline. Baseline is taking place. You can see that it's counting up on the right-hand side. Now if I just kind of put some artificial pressure in here, you'll see that number there, and I'm going to hit enter. You now see that the baseline is stored and visible at all times. I'm going to clear that. Over here on the right hand side, this is where most of the changes will take place. And this is where we're changing the mode, the fan, or the device, and its configuration. So I'm going to just press on the mode, and you'll see a variety of things taking place. Now this is a scrollable list, so you can choose a number of different metrics depending on what you're looking for. If we wanted just pressure, we could have that. Right now we have it set at flow at 50 CFM. Now I can set my device. You can see a graphical representation of your fan. So if I have the Model 3 fan, or if I have the duct plaster fan, you can make that adjustment and make sure that your system looks like what it is that you're testing with. And on the configuration, we now have the ability to pictorially choose what we have on there. So again, this allows the user to look at the gauge and compare that to the fan and the rings that are installed for the test. Does this match, does the gauge match what's actually being used to test? We have the ability to go ring B, C, we also have D and E. A lot of people don't use D and E because that's for very, 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 very tight houses, sometimes in the passive house configuration. But there's ring A, and then all we need to do is go back to our gauge, and you can see all of those are there. We have input identified here, so everybody has the ability to see that the input for channel A and the reference for channel A, input for channel B and reference for channel B. So that's kind of our that's our live demonstration for the moment. Here you can see that this is telling you that I've got a pretty good amount of battery charge. This is your network identification. So right now I have not chosen any form of networking. And if I had a Wi-Fi active on there, you would see the bars of Wi-Fi signal. So that is our live demonstration. I'm going to go back to the presentation. I think this might, bear with me for just a moment while this gets going. All right, so we've done our live demonstration. Ordering and availability information. Orders, we will begin taking orders tomorrow, September 1st. We expect deliveries to begin in the second half of September and no later than the end of September. Those people that order a blower door system with the DG-1000 will ask you whether you want the whole system to wait, or whether you want us to ship the blower door system to you in the DG-1000 when that's ready. Oh, I want to show one more thing. I'm going to go back to our live demonstration. Because I forgot to show you our case. Get that up a little bit higher. Here is the new carrying case for the DG-1000. You can see that it has industrial zippers. It is a soft case with stiffening throughout the case to maintain its shape. We have a nice firm handle so that it will stay there for a long time and easy to grip. Inside, this is where the DG-1000 would sit. If I pressed it all the way in, it makes it nice and flush. You can see here we have the battery charger. This is also the recovery disc. We ship that with each instrument. In the top half of the carrying case will be the certificate and the user guide. We also have room for our tubing, cables, and other supplies. Inside the carrying case, we are also sending along a packet of screen protectors for the gauge. It's not necessary, but some people might want to do it. It's just like your smartphone. These are just placed on the display of the DG-1000, and if they get messy, then just take it off and put on a new one. The other part of the DG-1000 is that we do have a new digital gauge board, because we have this form of connection. One of the things that we want to be able to do is get it to fit properly and easily. The gauge board also has cutouts for tubing management. You don't need the new gauge board, but it can be helpful. So I'm going to go back to the demonstration, or to the presentation. So back to the information about ordering and availability. You've seen the case. The price of the DG-1000 is $1,450, and that includes the capability to use the Wi-Fi network and all networking capability, and network capability that comes up in the future. So there's no gimmicks, no extras to buy, it's all included. There is a new gauge board to hold that. The gauge board is $60. Again, you don't need to have that. It's just an option that you might want to consider. But the magnets on the DG-1000 are rare earth magnets that will easily hold to any door or ductwork system. Now, this gauge, as you see it right now, is only for the United States. We do have a little bit of testing that is taking place for markets outside of the United States. We also have the ability to add languages to the DG-1000. So those certainly, even in the United States, may want to have a language other than English show up on the gauge. But certainly for, we want metric values, those need to be incorporated as well. So our first update, which should be happening in just a few months, will include languages as well as metric values. So right now it's English only, and with US measurement capability. So we already have some things identified for the next update, and we're also looking at various functions that will be added, and we look to have new features and functions will be added roughly every 3 to 6 months for the next couple of years, and we think that will make then a really complete instrument for everyone to use. So that's kind of the evolution of pressure gauges from the Energy Conservatory. We have our original Magnehelic gauges that the company used back in 1983. The DG-3 that came out in 1993. The DG-700 that started in 2004, and now the DG-1000 in 2016. So that's kind of our progression of instruments over time, and we hope that you'll really enjoy this this new product. So with that, we'll go to questions. There is, if you type in to your web browser DG-1000.com, you will see the latest information. We will be updating these specifications. We're in the process of creating the user guides and manuals, more videos, and a lot more information. So this information will be updated quite frequently during the month of September. So I'm going to go to a couple of different questions. So we have one here. The first is, when cruise is set at -50, will the gauge be reading pascals at 50? Yes, it will. Can you do a screenshot of this unit to record your results? We are working on some training material for this. Doing a screenshot directly from the gauge is not built into that, but that's a great question. We'll bring that back to our programmers and let them know that that would be a good idea. We do have some reporting features that we're looking at developing in the gauge in the near future. I don't have a lot of information to share right now because we're still working on all the details on that. Another question on screenshots, not sure what's meant by that, but we are looking at, again, the screenshot is one thing, but the data of the test, when it was done and things like that, are really important. We're also working on a new app that will provide more detailed information that can be given to customers. Multi-point blower door testing available from updates soon. The gauge is limited to the fact that there are 2 pressure sensors. So you can do 2 fans with general pieces of information, but multi-fans require multiple gauges because of multiple pressure inputs. So there's only so much that we can do with that, but we are looking at other apps and being able to control the gauge with fans. Will there be an app so that an inspector can view the readings on the DG-1000 directly on a smartphone? To a certain extent, that already exists. We have an app which we call iTech 700, which will soon be renamed to just iTech to TEC Gauge. That will be the application to use, connecting it with a Wi-Fi network so that you're able to read the value from the gauge that you're connected with and then send out an email or data to a customer. Can the gauge run a multi-point test without a computer? I'm certainly not right now. We are looking at a lot of different apps that we can incorporate into the gauge, but certainly for the next 3 to 6 months, that's not part of the gauge, but we are looking at future updates that'll have a lot more functions. On a future update, can a reminder pop up on the screen that calibration is due in 30 days? That's a great feature. I think that's something we're going to bring to our programmers and have them be aware of that. I like that idea. We are looking at a process where the Energy Conservatory will be sending out reminders about gauges due for calibration, certainly more than just the 1000, because there are lots and lots of DG-700s out there. So we are going to be creating a program where you will get email notifications that you have a gauge that's due. More information probably in the next 60 days on that. Is there a new and improved fan to go along with the new gauge? No, there isn't. We've been spending a lot of time on this gauge, and there's still more work to be done on this. And the intent of any of our new products is that any gauge that we come up with has to be backward compatible to all of our other systems. So this one will be working with all of the Model 3 fans, all of the Series B duct blasters, pressure pans, exhaust fan flow meters, true flows, and the like. So that's what we've been spending all of our time on. And a comment that someone really likes the gauge case. We appreciate that. We think it's going to be useful, durable, and easy to take around with you. So that's our 1 hour session. Really glad that everyone has been here to see this. Again, type in DG-1000.com in your web browser, or just go to energyconservatory.com and you'll be seeing more information. We will be taking orders beginning tomorrow. And so we hope that you'll be one of the first ones to receive that. With that, I thank you. We will be holding this again later this afternoon and again tomorrow afternoon. So if you would like to hear this again, please feel free to join in on our next ones. Thanks, everybody.